While Linode makes it super easy to go to cloud.linode.com and spin up a new server or other resources, when you're deploying production applications, you want to make sure that the resources can be deployed efficiently and repeatably. In this video, I'm going to show you how to do exactly that using a concept known as infrastructure as code, specifically using Terraform, an open source tool from HashiCorp. Hello, my name is Sid, also known as DevOps Directive here on YouTube, and I'm a developer advocate working with Linode. If you want to follow along with today's tutorial, there will be a link in the description that will give $100 credit when you create a new account, and it should be more than enough to get started. Okay, without further ado, let's get into it. I mentioned that we'll be using infrastructure as code. This refers to the practice of representing all of your cloud infrastructure using configuration files within your code base. Why would we want to do this? There are three main reasons. Number one, version control of your infrastructure. Because your resources are declared as code, you can track changes to the code over time in a version control system like Git. Number two, minimization of human error. Whenever you can eliminate a manual step in the deployment process, it eliminates the potential for a misclick or a typo to cause an issue. Number three, better collaboration amongst team members. Because infrastructure as code provides a single source of truth for the resource configuration, it's much easier for teams to collaborate based on this shared understanding. There's a variety of tools available to implement infrastructure as code, but one of the most popular is an open source tool named Terraform, and that's what we'll be using today. To get started, you'll want to have a Linode account set up, so if you don't already have that, go ahead and pause the video and create one now. We'll also need to have Terraform installed. Following the official Terraform documentation is the best way to install that you install with the most up-to-date method, but I'll go through the process here as well. Because different versions of Terraform may behave slightly differently, I'll point out that in this video, I'll be using version 0.14. If you're using a newer or older version of Terraform, you may have to modify the configuration slightly in order to get them to work. As I mentioned, the first thing that I'm going to do is download Terraform. I'm on Mac OS, so I'll download the 64-bit version here. It downloads in the zip file, so if I double-click it, it will extract that into an executable. And then I'm actually just going to move this into the working directory that I have here. So I'll move it here. And if I list out, you can see the executable there. I could just run /terraform, and that would work just fine, but I'm going to add it to my path so that I don't have to provide that / each time. In order to do that, I'll export my path variable, and I'm going to set it equal to my present working directory, colon, and then the current path variable. So that just takes my current directory and appends it to the front end of my path, and so now that Terraform executable will be the first version of Terraform that is found when I try to run it. So I can do Terraform version. And we see I'm running Terraform version 0.14.9. Now Terraform works by allowing us to contain our infrastructure in .tf or Terraform files using a custom language called HashiCorp Configuration Language, or HCL. So I'm going to create an example.tf file, and that's what we'll be putting most of our Terraform configuration within today. The way that Terraform works behind the scenes is it has what's called providers. Providers allow us to map from our configuration onto the API of whatever cloud we're using, in this case Linode. So I'll need to configure this provider and grant it access to my account using an API token. In order for Terraform to actually know where to find the code for this provider, we need to provide a path to the source. So we'll do that within the Terraform block. So within Terraform, we say required providers, and then we'll specify Linode. And finally, the source points directly to where this is defined within the HashiCorp registry, Linode/Linode. Next, we'll create a provider block. It's going to be the Linode Provider. Here we're going to have a token. This will be the API token to grant access to our account. For now, I'll just put an empty string. And then because I'm deploying a firewall, which is a beta resource, we need to specify that we're going to use the beta version of the API. So API version equals v4 beta. Great. What are we actually going to deploy today? We're going to deploy a Linode server. We're going to deploy a domain. We're going to deploy a domain record. And finally, we'll deploy a firewall. This Linode is going to run a basic web server, just a hello world. The domain will point to that, the domain record will point to that server, and then the firewall will allow inbound traffic on port 80 so that we'll be able to see it actually running in the web browser. Okay, as I mentioned, we're going to need to grab this API token from within the Cloud Console. To do that, we go to the cloud.linode.com, and up here in the upper right-hand corner, we can go and find API tokens. We then create a personal access token. We specify a label, so this will be Terraform Basics. And then you can set how long the token will last for. I'm going to set it to expire in 1 month. And then you need to pick the specific scopes for this token. So you can pick which types of resources this token will allow you to interact with. You can set them as read-only or read-write. In this case, because I'm using that beta resource, the firewall, I found that I actually had to grant read-write access for everything in order to get it to work. If we weren't using the firewall, for example, we might just set Linode to read-write, domains to read-write, and any other specific resources that we were going to provision. If I click Create Token, it grants me this token, and I'll copy that and put it into my Terraform configuration. Now this is a secret token and would provide access to my account, so I will delete this before this video is released. You want to make sure to protect this the same way you would protect your credentials to a database, etc. So I'll put that here in my configuration. And later, we're actually going to move this into a separate file that we can put in our git ignore so that it won't get checked into our version control system. Great. Now, the basic Terraform workflow is that first you run Terraform init. And Terraform init is going to download the source code for that provider, this Linode provider here. And it's going to get everything set up within my directory. As you can see, it created this .terraform directory, as well as this Terraform lock file. We haven't defined any resources, so if we do Terraform plan, there's no changes, infrastructure's up to date. What we're going to go through now and add each of these resource configurations, and then Terraform will be able to go in and provision those for us. Now we're going to define the configuration for our Linode server. We'll define a resource block. Within that resource block, we want to specify that it is a Linode instance type, and then we can give it a name. This is our local variable reference to that instance, and we'll just call it example instance. Within this block, we need to define a number of attributes of our instance, such as the machine type, the region that it will deploy into, what operating system it's going to run, etc. So I will put in a few resource attributes and save it. So this is the label that will be used inside of the Linode interface. This is the operating system that will be running, the image that we'll be running. We're going to deploy into the US Central region, and we're going to use the GS6 standard 1 machine type. If we had an SSH key and wanted to use that method to SSH into the machine, we could include it here. For now, I'm actually going to remove that, and we're just going to use a username and password. So the root password, I'm going to create some random characters here. And again, this is sensitive information. I'm going to move this out of my main file a bit later in the video, but for now, I'm just going to leave it here for convenience. Let's go ahead and try to provision this. If I do Terraform plan, like I did before, now I see that Terraform has spit out this configuration. It says 1 to add. It has all the attributes that I provided. And so everything looks good. I want to provision this server. I'll do Terraform apply. It asks me if I really want to, and I say yes. while it's creating that in the background, I'll describe a few different things. You'll notice that it created this terraform.tf state file. So the way that Terraform stores information about your configuration is in this TF state file. By default, it will be stored locally. If you want to work on a Terraform configuration with a team, you would need to store that remotely somewhere. And Terraform provides a cloud offering that enables you to store your state files in their system and collaborate with team members from within that interface. It's also important to point out that the state file will contain sensitive information, such as your passwords or tokens within it. So you'll want to take the necessary precautions to keep that file protected. Great, it says it was added. Let's go into the Linode interface and see that machine. Here we've got the machine running. Awesome. Next up, we're going to specify our domain. Again, it will be a resource block. It will be of type Linode domain. And we'll give it a name of example domain. For the purpose of this video, I'm going to use a domain that I happen to have laying around, and that domain is mysuperawesomesite.com. And yes, this is a real domain that I own. We also want to specify an email associated with that domain, and that will be sid@devopsdirective.com. Great. And the type of domain is master. All right, let's do a Terraform plan. We see that the domain is here. We don't see our instance, but that's because we didn't change anything. If we did want to change something, let's say, for example, we had changed this to a different machine type, and then we did a Terraform plan, it would show us that our instance needs to change and we need to add the domain. So that's just an example of sort of each time you run a plan, it will check your current deployed state against the configuration and tell you what the differences are. In this case, I want to keep that original type. So all I want to do is deploy this new domain. One to add, Terraform apply. Should be pretty quick. Yes. And great, it says it was created. So if I go here to domains, we can now see mysuperawesomesite.com is active with the primary domain here. Cool. We then also need to create a domain record to point our domain to the IP address of this instance that we created. That way, when we access mysuperawesomesite in the browser, it will direct that traffic to the server itself. So that will be a resource type, domain record. Again, I'll just change the reference name. And these reference names can be whatever we want. That's just an internal local variable for how we're calling out this resource. So I'll call it example domain record. Now we're going to use an internal reference to our domain to associate the two. So the domain ID here is going to be Linode domain. So I'm referencing this domain here within the configuration for the domain record to tie the two together. Example domain .id. We then also need to give a name for this record. For example, we could do www if we wanted that subdomain to point to this. In this case, I want the root domain to point to my server. So I'll provide the full domain here, superawesomesite.com. It will be a record type A. Record type equals A. And then we need to point it to the IP address of our instance. And again, we're going to use that reference syntax. So this will be target equals Linode instance dot example instance, if I could type, dot IP address. And finally, I'm going to set a time to live in seconds. This is how long the DNS system should cache this record. I'm going to set it as short as is allowable, 300 seconds, with the hope that it won't take too long for these updates to be made, and we'll be able to we'll be able to access it from the browser soon after creating the site. That looks good. I'll do a Terraform plan. One to add. It's going to add our A record, which is exactly what we want. Terraform apply. And we are added. Again, I can check from here. If I go into the configuration now, we see the... I don't see any... Oh yeah, here's the A record. And it's pointing to this IP address. Let's just check within our Linode. That is the same IP address for that server. So it did exactly what we wanted by doing that internal reference. Now the final resource that I want to deploy is a firewall that will allow inbound traffic on port 80, which is where we're going to set up a server that's going to run inside of our Linode. So to do that, we will specify resource again, Linode firewall, example firewall. We can give it a label, example firewall label, and that'll be the label that shows up in the Linode interface. We could give it some tags if we wanted to, but we don't necessarily need to. And then we need to define the different rules. So for inbound traffic, we're going to state that we're going to give a label to this rule, and this will be allow HTTP. The action is going to be to accept, because we want traffic on port 80 to be passed through this firewall to our instance. The protocol is TCP. TCP. These requests are coming in over TCP. On port equals 80. For IPv4, we need to set the allowable IP addresses that can make this type of request. The way that we specify the entire range is just with 0.0.0.0/0. That means any IP address these requests are originating from are allowable. And for IPv6, it's slightly different, but the way that we specify that any IP address is okay is with ff00::/8. Great, so that is our inbound rule. The inbound policy for everything else will be drop. So this says anything other than a TCP request on port 80 will not make it to our instance. The outbound policy for now, we're just going to accept all outbound traffic. And finally, we need to connect this firewall to our instance. In order to do that, we specify Linodes, and then we can specify an array within here. And so here we're going to point to our Linode that we configured above. Linode instance, example instance dot ID. So that will reference this Linode that we defined up here, such that the firewall will allow traffic to that Linode. Terraform plan. And Terraform. Everything looks good. That's how we wanted it configured. Terraform apply. Yes. Failed to create. The Linode that we tried to connect it to is not in a region where cloud firewalls exist yet. So this is still a beta feature, so it doesn't exist in all regions. So we need to make sure that we create our Linode in a region that is allowable. So the US Central region is not allowable. I believe that US Southeast is. So if we just modify this key, and this really shows the power of infrastructure as code, because we can just change this one key, do Terraform, apply, and it will actually delete our Linode in US Central, create a new Linode in US Southeast, and create that firewall with that one command. So everything looks good. I'll just say yes. See, it's destroying that first Linode. The destruction completed after 10 seconds, and now it's creating that Linode in the new region. Okay, it looks like it was able to successfully create our new Linode and that firewall. We can confirm within the interface here. So before we were running in Dallas, Texas. Now we're running in Atlanta, Georgia. So that looks good. And then we should have a firewall here. Example firewall on port 80. Anything that is not in one of our rules will use this default policy of drop. Great. So we have our basic configuration set up now. We have a Linode defined, we have a domain record, and we have a firewall. We do still have some shortcomings though. We have the sensitive data living within our Terraform file, so we can't actually commit this safely to our version control system. Instead, I'm going to move them out of our configuration using a concept known as input variables. So rather than have this hard-coded here, I can actually remove it and say var.token, and then create another file. And this other file I will name terraform.tfvars. And in here, I can say token equals, and then paste it in. And I also then, within here, need to specify my variables. So I'll put them at the bottom. The first one is going to be of type variable, and it is token. And so this just tells Terraform that I'm going to have a variable named token, and it will find it within this tfvars file and inject it when I run that Terraform apply command. I could also pass it in via a command line argument when I invoke Terraform apply. Okay, so token, that's great. I also don't want my root password here in the configuration, so I'll remove that and do var.rootpass. I need to specify down here, variable root pass, save, and I'll put this here, root pass equals, get rid of the extra quote. Awesome. So now I no longer have these sensitive data within my main tfconfig file. I also think I put this in the wrong directory, so let me move it out to the top level. Great. And then I'm actually going to create a git ignore file. And within that git ignore file, I'm going to put my terraform.tfvars. This would prevent me from accidentally checking that tfvars file into my source code. Now, the way that you would handle this in a team setting is you would actually store these variable files within the Terraform cloud offering as sensitive data, and it will handle that injection for you. Okay, great. Now we have our sensitive data removed from our main Terraform file, and we've extracted that into this tfvars file. The next thing that I'll want to show you is a concept known as provisioners. Terraform allows us to take certain actions after a resource has been deployed. In this case, once our Linode server comes up, we want to run a script that will start a web server for us so that we will be able to access it from the browser. Now, the way that I do that is specify it within my resource block for the instance. We will call it a provisioner. And this will be a file provisioner because we're going to create a file on our system that contains a very simple script. And then we're going to use that file, copy it into the instance, and then execute that instance. So first, I will create that script itself. So new file, this will be setup script.sh. And so this is just a very simple script, a very simple bash script that is going to take this string, hello world, from my Linode, and it's going to write it into this index.html file. Next, it will run this busybox httpd command on port 80. And so this just sets a simple web server up using this busybox Linux utility, and this nohup, when the user who initiated this command logs out, it won't terminate the process. So that will allow it to keep running even after Terraform has shut down that connection. I need to now reference that setup script .sh from within my file provisioner. And the way that I do that is with the source key, source equals setup script.sh. So that tells us which file we want to use as the source for this. We need a destination. So this will be where in the server it will copy it to. I'm just going to copy it to a temp directory. Setup script, not capital. And I need to give it a way for Terraform to connect to this instance. I'm going to use SSH for that. It will be type equals SSH. We need to point it to the IP address. So again, here we can actually use that same reference syntax, but I'm referencing the Linode instance within this, that this block is contained within. So I'll use the self key rather than the full path Linode instance, example instance that we've been using before. We are going to use our root user, and we're going to use that same root password that we defined before. So what this does is it takes this setupscript.sh script from our local file system, and once this Linode has finished coming up, it will copy that file onto the file system of that server. Next up, we need to use another provisioner that is the remote exec provisioner, and that's going to allow us to invoke this setup script and get that web server running. So again, we'll do provisioner, provisioner, remote exec, and I'm going to specify an inline command. So I'm going to say this will be the actual shell command that gets executed on the server. Inline equals, and I can specify multiple here. So the first thing that I want to specify is to change that script that I copied in and add the executable permission to it, because otherwise I wouldn't be able to invoke it. Next up, I will call that script. So I'll put a comma between each tag. And then finally, I'm going to add a command, just sleep one. And so I found that when I was testing this, it would run this script, and before it had even fully started that web server, Terraform would close the connection, which would cause it to not work properly. So by sleeping before I close my Terraform remote exec connection, it's able to properly start that script. Let's do Terraform plan. Root pass is not expected here. Sorry, I named this the wrong thing. The password within my connection is root pass. Also, I need to provide the same connection string or connection block within my remote exec provisioner, because it also needs to connect using the same mechanism. So Terraform plan looks good. So I'm going to Terraform apply. Now you'll notice that these didn't actually do anything. And the reason for that is these provisioners only occur upon the first creation of that resource. And so what I'm actually going to do is destroy my entire setup with Terraform destroy, and then re-bring up the entire configuration such that those provisioners will be applied. Again, this is the beauty of using infrastructure as code, is we can very quickly bring up environments, bring them back down, test things out, and get them working. Okay, the resources were destroyed. Now I'm going to go ahead and do Terraform apply to bring them back up. And this time we should see after that Linode is created, it will use those two provisioners to copy the file onto the system and then run that script to get our web server running. Okay, we see that after the server came up, it is now provisioning with file. Now it's SSHing into the machine and executing that script. Looks like we were able to create all those resources successfully. So now, if I go here into the Linode instance page and we check this IP address, if I just paste this IP address into my browser, I actually hit that web server that we just started and it says, "Hello world" from my Linode. Awesome. The final piece would be to see if our DNS record is successfully pointing to that server. I went ahead and added these Linode name servers to my DNS setup for this domain where I purchased it. So that piece should be good. DNS records, when you create them though, can take up to 48 hours to propagate. So I'm unsure whether or not this will work on the first go. Let's go ahead and try it though. Oh, awesome. So that worked. We were able to go to mysuperawesomesite.com. It routed us to that IP address of our Linode, and it accessed that web server through the firewall and was able to return that response to my browser. And so that kind of shows you the full power of getting started with infrastructure as code. We were able to spin up those resources, get them all configured properly, and now we'll be able to track changes for those over time as we need to modify them, add additional things, etc. There's a couple of additional items that I'll point out before closing out this video. The first is that we used this top-level example TF file and included all of our resources within it. Now, if we wanted to build our code in such a way that it could be reusable, we would use a feature called Terraform modules, and that would allow us to structure our code in such a way that we could have a reusable module, let's say a web server module, that might contain all of these resources, and then we could just update certain things via variables, input variables. So for example, let's say we just parameterized our domain so that we could put a different domain here. That would allow us to spin up a separate web server automatically and point it to a new domain using a reusable module. So that's a good feature to look into if you want to take your Terraform configurations and make them more reusable. The other thing that I pointed out a little earlier in the video is this local TF state file. By default, it stores our state locally, but if we wanted to work with a team, we would want to store that remotely somewhere. And the best place to do that is within Terraform's cloud service. So they have a cloud offering, this Terraform Cloud Edition, where you can store your state files and all your sensitive information within their interface and work with your team in a secure environment to do remote operations to provision and manage your cloud infrastructure. Finally, not every project will be starting from scratch. You may have a bunch of resources already provisioned within your Linode account. In the next video, we're actually going to go through and take some resources that were provisioned ahead of time and import them into a Terraform configuration such that we're able to use and manage them with infrastructure as code, even though we created them manually outside of the Terraform process. That's it for today. Hopefully that gave you a taste of how you can use infrastructure as code and Terraform along with Linode to make your deployments more reliable and more efficient. If you liked the video and want to see more like it in the future, make sure to subscribe to the Linode channel. Also, let us know within the comment section the types of videos that you would like to see moving forward. That's it for today. Take care.